everybody, my name is Apurva, and today I'm going to show you something that your teachers should be teaching you earlier. I'm not even sure when they teach you this, but I'm going to write it down for you. I'm going to be showing you the expansion, the general formula for the expansion of a plus b to the power of n. N can be any number. So you might ask, what is this? Okay. So to answer that, I will so we'll get to what that is in a moment. But now let us begin with something a little easier. Okay. So everybody, I think most people who are I hope watching this video will hopefully know what the expansion is of this. I think we've all learned this in school. It is a square plus 2ab plus b square, right? There's also one more thing we have learnt in school, and that is a plus b the whole cube. I think we have memorized this, but not really understood what's going on. I mean, surely you can figure out why this is true. You can just do the multiplication. But what happens if you start going to higher powers? There are pattern that you're gonna see. Okay, let me just write down this expansion because we're gonna need it. Hmm. Yeah. So now what is a plus b to the power of 4? Now, I don't think we've been taught this at all in school. Nobody teaches you what this is. So let's find it. So obviously we know if you can split the power and do a plus b to the power of 3 times a plus b. And we know what a plus b to the power of 3 is. Here's this. So oh yeah, and in case you haven't been taught what a plus b cube is, you can just do this multiplication process using what a plus b square is. And if you haven't been taught this, you can just start from scratch and do a plus b times a plus b. We're not going to get into that. I'm just going to jump at this step. So, actually, wait, you know what? Let me just copy them. It's going to be faster. Uh, is the select button? Ah, there we go. So, this. Okay, hang on. There we go. So I'm just gonna move this here. Now I'm gonna head back here. Wait. Okay, now. Uh, yeah, okay. So you have this here, and I'm just gonna move this here. There we go. I'm just gonna put this here. So you have this, which is the a plus b the whole cube, times a plus b. So what are you going to get on the other side? Well, we can do the multiplication. So here we're going to get a to the 4 plus, well, here you have 3a square b times a. So that's going to become 3a cube b plus, then here you have 3ab square, but you're multiplying by a, so you'll get 3a square b square. And last but not least, you have a b cube which will get multiplied by a and become a b cube. Okay. Now next, we're going to repeat this process with b. So plus what's it? Yeah. So b times A cube is going to be A cube B. And you've got 3a square b times b, so that's going to be 3a square b square plus 3ab square is going to be 3ab cube. And last but not least is b cube times b, which is going to be b to the fourth. Now let's simplify a bit. So to simplify, what I'm going to do is I'm going to mark out the ones. So a to the 4, a to the 1 second. Okay, hang on. So on the thicker side, 1 second. Hang on, let me just rewrite this 8 to the 4 again. So now I'll use red. So red is our current color. So 8 to the 4, we'll just copy that as it is. You've got 3a cube b. Do you see another a cube b? Yep, we see one here. So we'll cut out both of these. And since that's 3 and that's 1, that becomes 4a cube b. Plus, we see a 3a square b square. There's another one. So we'll cut both of them. And together 3 plus 3 is 6. So 6a square b square plus ab cube. There's another ab cube here. 3 plus 1 is 4. So you get 4 ab cube. And last but not least, there is b to the 4. And this is our final equation. So, with this being said, I think we might have noticed a little pattern here. Over here, no, no, that was not intended. No, 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 1 second. Okay, whatever. We're just gonna leave that. Why is it? Anyway, back to the point. So here you've got this. So at here, if you notice, A's power is decreasing. Here it's A to the power 2. Here it's A to the power 1. And here it's A to the 0. Anything to the 0 is 1. So it's just B2 times 1. That's why it's just B square. Sorry, not B2. It's B square. And you also have, yeah, and then you also see the b power is increasing. Here b to the 0, that's why there's no b here. Then b to the 1, you don't write the 1. And then b square. Same thing applies to here, the cube one. A cube plus a's power decreased, b is increased to 1, and b's was 0 here. Then a's decreases to 1, b increases to 2. And last but not least, a becomes 0, b becomes 3. So you've noticed that the value, even in this last one, it's just decreasing. So if you've noticed, the values of a keep on decreasing starting from the power until it becomes 0, and the values of b start from 0 and go to the power. So we know for this a plus n, you can just write down these terms right now. If now let's say I were to told a to the 5, I mean surely we can just write down everything, right? We could just write 1 second. Why is it on the thickest? There we go. We can just write a to the 5, and now we know what to do. We can write a to the 4 b dot 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 dot. You get the point. Until b to the 5, etc. You get the point. But the thing is, all of these have these coefficients. Even this has a coefficient of 1. It's invisible, but they have coefficients. So where do these coefficients originate from? The answer lies in Pascal's triangle. Oh, oopsies. Okay. So Pascal's triangle starts off with 1. And now you gotta pretend there are imaginary zeros here. So these zeros aren't actually there in the triangle, these blue ones. So I'm going to erase them later. So now you do 0 plus 1 is 1, and 1 plus 0 is 1. Again, add more zeros here. At this point, I'm going to stop adding zeros. Everybody, so 1, then below these two, 1 plus 1 is 2, 1. I'm going to stop adding the zeros. You know what? I'm just going to erase them now. Think we all understand there are zeros there. So now 1 plus that imaginary 0 is going to give me 1. 1 plus 2 is 3. 3. 2 plus 1 is 3. That is 1. And now again we do it again. 1, 4, because 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And that's 1. The coefficients are matching. So the way you label a row of this triangle is by you start labeling the rows from 0. And the row also happens to be the power, because in in a plus b to the power of 4, it uses the numbers on the fourth row. 1, 4, 6, 4, 1. It's the same thing for a to that. The power is 3, so you use the numbers on the third row. Now this seems simple enough, and you can just find all the rows here. But here's the problem. If I had to find a plus b to the 100, it would take forever to write out a triangle. Which is why there is another way of finding a particular row, you can, or a particular thing. So let's say you want row 4, and you also count these positions. So 0, 1, 2, 3, 4. Right? The last position is the fourth position. Third, second, first, 0. So you label them from 0 as well. So let's say you wanted this number. There is a way of figuring it out. And that lies in a little bit of combinatorics. So, so I can rewrite this triangle here as, I'm going to just explain what this is in one moment. So the top number is the row number, and the bottom number is the index number of the row. If any of you know coding, this is like a 2D array. It's basically a 2D array where the array size is increasing by 1. I'm talking in coders terms, so maybe not everybody would understand this. But basically, the index of the row is on the top, so which row, and then this is which position on the row. So 3, 0. Oh yeah, and by the way, just in case, these are not fractions. And that, oh wait, hang on, why am I drawing the fraction sign? I just said they aren't fractions and I'm drawing it. Anyway. So these aren't fractions because they are in brackets A, that makes a difference. And secondly, well, oh yeah, by the way, this is not a one-to-one correspondence. Pause. I'm going to make a little note here because it's gone a little wonky because these are slightly fatter. It's gone really wonky. So I'm just drawing lines here to correspond for which row they are. It's not true that this goes to this, no, because then it's just fatter. Anyway. So you might be like, okay, this is a nice labeling system. But what's the point? I mean, like, if you know, let's say if you know a label, how can you get back what it is? That's because the labels are related to the answer. So, actually, so wait, these act like indexes, but in reality, if you're given it without the triangle, if you have a thing nk, it stands for if you have n number of items and I want to choose k, whereas where the order doesn't matter. I'll explain what that means in a moment. The answer will be equal to its corresponding thing, which I'll also explain in a moment. So let's just get started first by what I mean by choose things where order doesn't matter. So I'm going to show you something where the order does matter. So you have, so you are gone to a shop, an ice cream shop. They have a beautiful array of 6 flavors. They've got an array of 6 flavors. Okay. And out of them, let's just call them, the flavors names don't matter. The point is, you are going to have a 2 scoop ice cream. And the one rule is that both scoops have to be of a different flavor. So I'm just going to draw 2 different circles to indicate that they aren't the same flavor. So you can't have a double scoop of chocolate. No. Let's say you don't want to, or let's say there's a rule there, or you get like a free discount if you don't keep them together. Whatever. The point is, you're not allowed to have that. How many different options can you make of this double scoop ice cream? Let's say you come to the shop every day. How many days will you be able to buy an ice cream without them repeating? Well, let's talk about this. So, as you can see, for the first ice cream scoop, I can choose any 6 of them, right? The first one can be filled with 6 flavors. The next one can be filled with the remaining 5. Now, the reason I'm multiplying is for each one on the base, there are 5 I can put on the top. So that's why it's multiplication. You get 30. Okay. But we can write this kind of systematically by using, so wait, this involves using 6 and 5. So I suppose it makes sense. However, can we write this in such a way that it involves the number 6 flavors and 2 scoops? And indeed, yes, we can. So there's something that you need to know about combinatorics. Oof, sorry. Okay. Something you need to know about combinatorics, which is called a factorial. So let's say you have 5 factorial. It basically means 5 times 4. So you keep decreasing it by 1. You just multiply them all and just decrease it by 1. And the reason is 5 factorial is basically the number of ways you can arrange 5 objects. So if you got 5 tokens, each one labeled 1, 2, 3, 4, 5. How many basically orders? So I can write 1, 2, 3, 4, 5. Then I can write 1, 3, 4, 5, 2. Basically, how many possibilities are there? Out of 5 tokens, you have to use 5. How many total possibilities are there with order? So this is 5 factorial because the first token can be any of the 5. The next one can be any of the 4. The next one can be the remaining 3. The next one has to be the remaining 2. And the last one has to be whatever's left out of the 5. So this is 5 factorial. So basically, the general factorial is n factorial is equal to n times n minus 1, n minus 2, etc., 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 times 2 times 1 until you reach 1. I just ran out of screen space, no problem. Times 1. Okay, so we've understood factorials now. Back to the ice cream problem. So, can we write it in terms of factorials? Oh, yeah, by the way, there's a proper name for this. It's called 6 permutate 2. So, out of 6, you choose 2. You choose 2, but you can permutate them. So, how would this work? Well, we said that the answer was 30, which is 6 into 5. Now, 6 into 5, if you didn't realize, is a part of 6 factorial because it has an extra 4 into 3 into 2 into 1. So we can write here, 1 second, let's just move down here. We can write here 6 factorial. However, we are deeply overshooting because there is that extra 4 into 3 into 2 into 1. However, 4 into 3 into 2 into 1 is 4 factorial. But Cliff, where is the number 4 appear in our statement here? I said we have to use it in terms of 6 and 2 factorial. That's where, because 4 is 6 minus 2. Yes. 6 minus 2 factorial. Okay, all's well and all is nice. So this is the answer. You will still get 30 because, well, 4 factorial will cancel out the 4 into 3 into 2 into 1. You'll be just left with 6 into 5. Answer solved. So if you have a number n, p, r. So r is the so if you have an n number of items and you were to take out r in an ice cream scoop where the order does matter. So putting vanilla on the bottom and chocolate on top is different from putting chocolate on the bottom and vanilla on top. The answer is n factorial divided by n minus r factorial. Okay, now back to the case of this brackets nk. So instead of r, I'm just using k for this. Now, what does this mean? It means that you have 6 flavors of ice cream. You've got good old 6 flavors. Okay, how about this? You know what? So, this permutation thing isn't important right now. We'll talk about this later. Just remember this for a moment. Let's move up again. So, you've got 6 flavors. You have to choose two. However, it's in a cup. Now you might be like, okay, what difference does this make? Because you can't order items in a cup. Okay, you know what? This is a very bad cup. How about this? Let's just do the cup from the top angle. Let's just do a cup from a top angle. This is a cup from the top angle, and then there are 2 ice cream scoops inside. Strawberry and blueberry. It doesn't matter actually what flavors there are. But yeah, okay, there are 2 flavors. They have to be different again. They have to be different. However, the order doesn't matter because in a cup they just slush around. I mean, you can't say like, and it doesn't matter which scoop goes in first and stuff. You can't order which scoop is in whatever. Unlike a cone where you can say there's a fine order, here there isn't any order. So now what do you do? Well, if you use the formula that 6 factorial divided by 6 minus 2 factorial, the problem is you're double counting. What are we double counting? Because in this case you're double counting the fact that the order doesn't matter, right? The thing is, for every for every possible, so if when strawberry and blueberry go in, you are counting strawberry bottom, blueberry top, and blueberry bottom and strawberry top as 2 different things. But in this case they are not. And in fact, for even let's say if we had to put 3 scoops, then there would be a total of 3 factorial overcounts more, because you could arrange those 3 scoops in 6 possible ways and you would be counting each one separately. I mean, not 6 factorial, 3 factorial ways, which is 6. So the answer, you have to divide this by 2 factorial. At the number of combinations you can permutate the chosen value. And this is called 6 choose 2. Or you can use this notation. In calculators, it will be shown as NCR, but the other notation is this, which is also represented as, it's NCK, but you write it like this with the K instead. The general formula for N choose NCK is N factorial divided by K factorial times N minus K factorial. Okay. So now we know how we can find any index on the triangle. So now what I'm gonna do is I'm just going to get rid of all of this because now we have sorted this out. We'll head back over toward the top. To head over to the top here. Yes, there we go. One second, let me just erase a little extra stuff. We don't need this now. So now we've understood what this notation means and how it'll find us. So the fourth row and the zeroth place on the fourth row, which means 4, choose that, and you can actually do the math. Oh yeah, by the way, 0 factorial is 1, not 0, just in case anybody thought. Because if you have nothing, how many ways can you arrange nothing? One way. So that's why. Some people will be like, hey, it starts off 0 because you said n Zero is kind of an exception. 0 factorial is 1 basically. And I just showed you why. Oh dear. Uh, yeah, okay, now finally to this point. So now we can find out any row. So if we wanted to find out what it is to the power of 5, we don't need to write the fifth row. The way of we need to write it. And now wait, by the way, I'm not going to actually solve what that is. You can solve that later. So it's going to be the 5 0, okay, a to the 5, b to the 0. Then the next term is going to be 5. So we are still on the fifth row, but the next index 1, a to the why am I writing 5? It's a. A to the 4, b to the 1. Now I think people are noticing what's going on here. Obviously, you can later just use the formula and figure out what these numbers are. It's you, and you can already see it's just 1 5 10 10 5 1. But the point is, it doesn't matter what the numbers are. You can always figure that out using my formula, even if you don't have it. It's n. Oh yeah, wait. Let me just write that actually, because some people might forget here. I'm gonna write that important note. N K. Okay, wait, I'm just writing this here as a general statement for us to use later on in reference. And eh, there we go. Okay, we'll just keep that there. So you can just find out these things later on. So you get this. I think people are going to start to notice a pattern here. And you do 5 second index. If you notice the pattern, good for you. I'm gonna just reveal the pattern in a moment. I'm gonna write the entire expansion down here. This expansion is correct, by the way. It's just that I haven't solved for these. Anyway. So I'm gonna just give you all some time to figure it out while I just write this entire expansion. Some might have figured it out, some may not have. At the end of it, I'll give you all a couple more seconds to figure out what what is the pattern, and then I will reveal it to you. Then we can get to writing the general answer for it. Oh yeah, hang on by the way. And I'm almost done. Hopefully you guys have found it. Hopefully you guys have seen the pattern. Okay. And I'm just gonna zoom out so that here is the full equation. Now, do you see any pattern? I'll give you all a couple of seconds more. Okay, now I'm gonna reveal what the pattern is. If you want, you can pause the video and still try to figure it out. I'm gonna reveal it now. Just pause it right now if you don't want me to. If you don't want to see the answer right away, and just ponder upon this. Okay. The thing is, you see this, and so wait. If you notice this value here, the index on the row is matching the power of B. And the power of A is the difference of the two, the row number minus the index. See, 5 minus 0 is 5. 5 minus 1 is 4. So it's always 5 minus B's index, which is just the index of the index on the row, like which number it is on the row basically. So 5 minus 1 is 4, 5 minus 2 is 3, etc. 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 So this will allow you to get a general formula for that. Now you might be like, oh, okay, job done. As soon as you write it, we're good. Except that there is a simpler way of writing it. Okay, I can zoom in now. There we go. So here we have A plus B, the whole raised to n. Now you might be like, why aren't you writing it at the top? Because we can still further simplify this, and I'll explain how. So it will be n 0, a to the n, b to the 0, plus n 1, a to the n minus 1, b to the 1, then etc etc etc, and then finally you reach n minus 1, where the index has reached n minus 1, a to the 1, b to the n minus 1, and then you get n n, a to the 0, b to the n. So this is the general answer, except it's kind of like this infinite dot 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 series type thingy. So we can write a general term. So any term of nk, so any term is going to be, any one term will look at this format, where k can be anything, k can be 1, k can be n minus 1, whatever. Any term in this equation is going to look like this. Any term, any one that you will find will look like this, where the index on the row of the triangle, on the Pascal triangle, will match, not the index of the row, the index of the number on the row will match b, and then the row index minus the current one, the current number which you are on the row, n minus k is the power of a. This is the general term, but this is obviously not the answer, because this is just one term. So you've got to just keep increasing the value of k. Now, how do you write this as a neat, nice formula? And that's where a good old friend can save us. I don't think I've discussed this before. You might not know this. It's called sigma. At this point, people are like, what is sigma? It's simple. Let's say you have a value I, the iterator, is equal to, let's say it's equal to 1. And you have got a value. Okay, by the way, this is just a very fancy way of writing something we all know. And let's say the highest value is 5. And now here I'm going to write 2i minus 1. People are confused. I'll explain. So what this does is you start off with I equal to 1, because that's the base value. So and now you put it in this equation. 2 times 1 is 2, minus 1 is 1. Now you put a plus sign. Now make I2, put it in the equation. 2 times 2 is 4, minus 1, 3. So as you can see, sigma means sum. S is sum. Sigma means the sum. So now is the sum function. Okay. Then when I is 3, 2 times 3 is 6, minus 1, 5. You always put a plus sign. So you are adding up all the values as I increases. Then when I is 4, the answer is 7. I think people figured out these are just giving odd numbers. When I is 5, the answer is 9. You can check it yourself. I'm not gonna just keep talking about how it is. And if you sum them up, it's 4. 4 plus 5, 9. 9 plus 9 is 18. 18 plus 7 is 25. So this is the answer to the equation. Now, in case somebody did notice a little suspiciousness going on here, 25. Hmm. Isn't that 5 square? And wait a minute, the upper limit is 5. Yes, indeed. If this upper limit is some value n, and you put it in this equation, the answer you are going to get is n squared. Always. So I think we've understood what sigma is. This is just a simplified sigma. Now, to the actual sigma we need to write. And this is what I'm going to write. So we know the general term is this. And if you didn't notice, wait a moment. No, I don't want to bring back sigma. If you didn't notice that if the general term is this, And you see k is increasing one by one and its base value is 0. So wait for it. Okay, we're gonna have to head all the way back to where we began at the top of the page. Right here, we the general, so it's going to be sigma. The general term is, so the not the general term yet. So k starts off at 0 and we saw at the end of, you know what I'm gonna do? Second, I've got a nice idea. I'm gonna just zoom out here real quick. I'm gonna swap to my eraser. All of this previous stuff here is now unnecessary. All of this. The general term is all we care about right now. So wait, we figured out, as you can see here, I'm just gonna zoom in a little bit. So you can see the ending k becomes equal to n at the beginning at 0. So we know the upper limit is n. And one second. And now this, I'm just gonna drag it to the top here. Just gonna, oh no, oh no, 1 second. Again, yes, there we go. So we're just gonna bring the general term to the top. I'm just gonna zoom in. So this is the general term. And also wait, I forgot to write the upper limit of n here. And since this is the general term, so k keeps increasing for that. And this over here is the equation to a plus b to the power of n. It works every time. You have to keep incrementing k one by one and adding it to the previous terms. K, and we know what nk is. Hang on. And everybody knows what that nk weird looking fractional thingy is by the end of this video. No, I don't need the ruler. That thing means this. And there you have it. Over here on top is the answer. So nk you can figure out by using this. Everybody knows basic exponents. There's no simplification there. So basically all you need to know. So what I explained was really in depth and honest. I could have just told you this and explained what a factorial is, and you would have gotten along well. But obviously, I had to explain everything because that's what interesting, right? I mean, just being taught of formulas, makes you wonder why are things correct. So I gave this explanation. Now you understand why a plus b to the power of n equals to this. So now, if somebody hasn't seen my video, most people in your class, whatever age you are probably going to be like, "What is this? What is this?" They're going to be absolutely confused. Maybe they might know this. Maybe you've been taught combinatorics, hopefully. But I don't think sigma has been taught to most people watching the video. So basically, this is the answer, and now we'll wrap up So the conclusion is this is the answer, and nk is this. We know what a factorial is. Okay. Now, thank you everybody for watching. Please subscribe to my channel for more content like this. Don't forget to like this video and share it with other people. And what was I? Yes, of course. If you want to get notifications, not necessary, but if you like my videos and want to be notified when I release the next one, please do turn on the notification bell so you don't miss it out. Otherwise, like, you'll just miss it out and you'll be like, oh, wait, hang on, when does this video come out? Okay. Anyway, time to wrap up. See you guys next video. I'm not sure when that is. Bye.